Today, we're going to be taking a look at data sets and also data loaders within PyTorch. Now, this is going to be one video in a full series that I am developing. Now, you will be able to learn both of these concepts in this videos without watching everything else in the series. But if you're brand new to PyTorch, I recommend watching some of the previous videos. So more explicitly, like what are some of the different concepts we're going to be covering in this video? Well, first, we're going to be creating a custom data set class. And then we're going to have in there a few special dunder methods, which is going to be the init, len, and then also get item. Then we're going to be creating some data loaders with multiple parameters. And then after that, we're going to iterate through these both in the training and also eval loops. And what's interesting too is in all the other PyTorch videos so far, in our training loop, we've only had one for loop. This time we're going to be using two. And in fact, we're going to be using one for loop as well in our testing. So this video does get a little bit more advanced than the other PyTorch videos I have here on the channel, but we're going to continue to add complexity to our models. With that being said, I'm going to jump on Google Colab and let's start coding. All right, so let's get started. We're going to import a bunch of stuff here at the top. So import in torch, right? Then we're going to import in torch.nn as nn. It's for our class that we're going to create. Then we're going to do import torch.optim as optim. Okay, from torch.utils.data, which this should be brand new. We're going to import in two different things. We're going to import in dataset and also data loaders, or it should be just data loader. We haven't covered that yet, so no worries. Then we're going to grab our dataset that we want. I'm going to go just from sklearn. So from sklearn.datasets, import in our load digits. Okay, then what we're going to do is from sklearn.model_selection, we're going to import in our train test split. Okay, from sklearn.preprocessing, we're going to import in our standard scalar like that. Then from sklearn.metrics, we're going to import in our accuracy score. So accuracy score. I think we should be good. No typos. They'll take a little bit to run, but we'll start our next line of code. So let's bring in our digit data set. So we're just going to say digits equal to load underscore digits over here like that. And then up next, we're going to do X and Y equal the digits dot data and then digits dot target. Again, essentially we're trying to predict our target, right? So this is all of our different columns. This is our target here at the very end. Because the focus of this video is going to be creating this custom data set class as well as creating these data loaders. All right, so what we should do now is split our data. So let's do that. Should be super familiar with this. So X train, X test, Y train, Y test equal train test split. Throw in our X, throw in our Y, test size equals 0.2, and say a random state equals, let's pick a number today. I'm going to throw in 11. Okay, great. So now we have these four over here. And what we should do first, before we even build out this custom dataset class, is we need to scale our data. It's very common within PyTorch and recommended. So let's do that. So standard scalar, then we're going to have X train equals scalar dot fit transform. Throw in our X train over here. And this should be train, not test, but okay. And then we'll have our X test equals scalar dot transform. Throw in here your X test like that. So X test, X test, X train, X train. Should be good. Awesome, we are. And now what we can do is we can start building out our custom data set. So let's write this out. So what we're going to do is class, we're going to have a custom data set, and inside over here, we're going to have data set. Okay, awesome. Now our first line is going to be our init. So we're going to say def, we're going to put init. Again, this is a magic or dunder because it has the 2 underscores, which I forgot the second one over here. And then what we're going to say is self, right? It's the instance itself. Then we're going to have data, and then we're going to have target over here. So now we need to build these out. So self.data equals, and we're going to do a torch.tensor. Then we're going to throw our data in over here, right? And then we're going to say this D type is going to be equal to torch.float 32. And then what we need to do is self.target, right? Again, like here are X and Y, data and target. So we're going to say that's equal to torch.tensor again. Well, I could honestly copy this same code pretty much. We're going to make a few changes. We're going to say our target is here instead of data. And then what we're going to do is a torch.long there. Okay, now what we're going to do is we're going to have our second method in here, and this is going to be length. So def, have underscore length like this. And all you need to put is yourself in here for this specific instance. And then you're going to just return length, and then we'll say self.data, right? And total number of samples within your data set. And finally, we're going to do our get item. So get item. And so these are 3 that you're going to see in your custom data set. And we'll expand on this in another video. But for this one in itself, this is what we're going to start with. And then self, and then we're going to put index. Sometimes you'll see in code, it's going to be IDX, or you can put index like this. So be familiar with either of them. If you have a preference, put that in over here. Okay, so then you have this over here. We'll say like our sample is going to be equal to, throw this in here, right? Let's say data, grab this over here, self.data, and then throw your index right here, okay? And then we can do the same thing with our target. So target, and again, you could change these like the X, Y, however you want it, right? Doesn't really matter too much, but I'm just gonna put data and target for this video and say self.target, and then we'll throw over here our index as well, or you can put your IDX. Should be good here once we have our return. So just put our return sample. I think we should have everything. It should not be indexing. It should just be index. I just automatically filled that out. Okay. So now what we're going to have to do is create some instances. I'm going to do our training data set and also our testing. Remember, our training has X train and also Y train. We have X test and Y test, which goes back into our, over here, our data and target. So great, both of these, not too bad, right? So we're going to say train data set equals custom data set for this over here, X train, then also our Y train. And then just going to copy that, and I'm going to call this our test data set. So test data set, and then we'll just throw a test right here for both of these, and we should be good, right? So awesome. Now we have those there, and just to show you like what's going on over here, let's take a look first at our length or len right over here. So this is pretty easy. len, right? You can throw your train data set in here. So you can see we have 1437, right? If you want to do the same thing with our test side of things, or just test in here, right? 360. And we declared that over here, test size, right? 20%. So we did the math on that. It's about right over there. And then also, I just want to show you too how this get item works. So let's just grab an example of that. So let's have our train data set over here. Let's just throw in 0. So whatever our first side of things is going to be. And then we have this tensor that's going to be outputted. So all this data over here. Awesome. So just to kind of reiterate this first part of the video, right? So none of this over here should be too bad. This time we added in our dataset and data loader, which might be new to you. Then over here, right, we just imported in our digits dataset from sklearn. We split, we scaled, so it should be self-explanatory. Then over here, we created our custom dataset. Now you need to have 3 methods in here. So we have our basic init over here. So this takes self, data, and also our target. So essentially your X and Y, right? Don't get those confused. So self.data equals, we created a torch.tensor, right? With data, our target or Y, right? Torch.tensor target D type over here. Then we have this length, right? So length of our self.data. And then we have over here our get item. So if we wanted to grab an example from our data set, we could just pretty much do what we did down below, right? So find a length, just call length, put your train data set or test over there to see how many samples are in there. And then if you want to change this specific index, right? Like let's say I wanted to see what our 1 was instead of 0, right? But I just want to show you 0 as a quick example. So that's what we did so far. Let's move on to the next section, which is going to be our data loaders. So we're going to create 2 different data loaders. Let's start off with building out our train data loader. So let's put train data loader, and that's going to be equal to data loader like this. Okay. And the first thing we're going to do is call our data set. So our data set in this instance is going to be this train data set, right? Which we called up over here, right? So just grab your train data set and put that over here. Up next, we're going to have our batch size. So how many samples are going to be for each specific batch. You'll see this when we start doing our for loops, cover a little bit later. But what I'm going to do is batch size equals 32 for this case. Then if we want to shuffle things up, great. So I'm going to say shuffle equals true. And then num workers just makes your code run a little bit faster. I'll just say that equals to 2 over here. Now I'm going to essentially copy this code. I'm going to put shuffle for false on the next side of things for our test. So test over here. Then we just need to change this to our test data set. Our batch size will be 32 and we still have num workers of 2. Run this code. We have that running now. Awesome. So let's create our simple neural network on this side of things. So I'll build out a few new lines. So class simple NN. We can grab our NN.module in here. And let's start going through this. So like always, build out our dunder init over here. So what do we need over here? Well, we need our self, right? We need to always have our input size. We always need to have our output size, but I'm also going to do a hidden layer. So let's save a hidden size, and then we'll also have our output size. Don't necessarily need the hidden size, but whatever, right? Just show you guys different examples. Then we're going to super this. We're going to throw in our simple and self. We're going to say dot init. That's okay. All right, so now let's just build out our layers. So we're going to start off with self.layer 1. That's going to be equal to nn.linear. This, okay. We're going to put in our input size. Then we're going to put in our hidden size like that. Okay. Now we're going to have a relu. So that should be familiar from our activation functions video that I covered. Very common. So it's going to be equal to nn.relu. I always forget about the capitalization here at the end. And then we'll do self.layer 2 equals, and we'll just copy this nn linear. Guess I could have typed it out faster, but, and then we'll have hidden size and then our output size. Remember, our output over here needs to be our input over here. So we have that. Okay. Now we need to set up our forward pass. So def forward like that of our self and also our X, and just put all your layers, right? So X equals self layer 1, throw in our X, right? And we'll put over here our relu. again, so many different ways you could do this over here with the code. Return X. I'll change this to 2 over here, and our reload's in between. Put that there. And that's our simple neural network. Hopefully no errors. And now what we're going to do is set up our training loop. So we need to define a few different things on the outside. So first what we're going to have to do is input size. So that's essentially going to be equal to our x train dot shape. Throw whatever index you want over here. I'll just put down 1. Then we need to set up our hidden size. I'm just going to call this 64 for this example. Then we need our output size, and output size, that's going to be equal to length like this. But we're going to just do a set. So this is just going to give you different unique classes within this data set. So, and I'll put our Y train over here. So we have our X train and our Y train, right? Input, output should be good with that over here. Now let's define our model. So we're going to say our model equals, we have this simple NNN. So we'll say simple NN. Now we can literally just copy these 3, right? So again, it takes input, hidden, and output. So input, then we have hidden, then we have our output. So just put those in here. Then we're going to set up our criterion. So that's going to be equal to nn.cross entropy loss. This is technically a classification question. And then you need to set up your optimizer. Now we're going to do optim. I don't know if I've used atom before in a video. We're going to use it for this one. I'm going to say model.parameters. Then set your learning rate, which you can call on the outside or you can call it over here. We'll say it's 0.001. Great, no errors. Okay, so now we're going to be into the training loop. So this shouldn't be new if you're already into the series, but again, just created our simple neural network, right? Very common super, inherited from this nn.module, created a layer. We threw a relu over here to add nonlinearity to our specific model. And then layer 2, our forward, right? You could literally just put this technically in one line of code, but I like writing it out sometimes. Then over here, our input size, hidden, output, just so we can call our model. Then we set up our criterion and then our optimizer. I know there's a lot to these models, but here's where stuff slowly gets a little bit more difficult. Let's start with building out our training loop. So now we're going to add in the complexity of having 2 for loops in here. All right, so let's set our number of epochs. We're going to set that equal to 10. And we're going to start off with some code you should be familiar with. So epoch, like type it right. So for epoch in range, then you throw your number of epochs in here. Again, should be the same. And first thing we're going to say is model.train. Okay. Now on the outside, we're going to also do a running loss. So we can do running loss equals 0.0. And that's just because we're going to be building out this for loop. So here's what's going to be new. So we're going to do for, we're going to say batch in, and then since this is our training loop, right, we're going to grab our train data loader. Okay. So we're going to take a look at each batch in our train data loader and through this for loop. So first we're going to take a look at our inputs and outputs, or inputs and targets, right? So it's going to be equal to batch, and inside over here, we have our data. Okay. Again, if we go back over here, we have self.data within this custom data set and self-target. So when we're going back over here, right, we're taking a look at our inputs. It's going to be equal to batch data. And then our targets, in this case, equals batch. Throw your target in here. Again, just think of like X and Y as well. That's a little bit confusing between inputs and targets. But if you're watching this video, I'd assume that you know this. But I always want to tell that in these videos. But regardless, right, inputs equals batch data, targets equals batch.target. Okay, So now what we're going to do is optimizer that 0 grad. Great. Now what we're going to be taking a look at is our outputs. So outputs equal our model, but you throw your inputs in here, right? You throw your X into your model. Great. Then we're going to say our loss is going to be equal to criterion, which we defined right over here, right? Our criterion. Then we're going to have over here our outputs. And then we're going to also have our targets. Hopefully everything's clicking right now. Great. Then we're going to do our loss dot backward. And finally, we're going to optimizer dot step. Ooh, all super familiar. Then we need to calculate a running loss. So running loss, we're going to say plus, plus equals loss dot item. So it detaches, right? That's what our dot item does. Plus equals, so as it runs through this for loop. And now we can print out over here essentially what we want. So we're going to say print. I'm going to throw this over here. And we're going to say epoch. And over here, we're going to say epoch plus 1. And divided by, over here, num epochs. Epochs. Great. We're going to say our loss over here. I'm going to say running loss. Go by train data loader. Just make sure this code is correct. Epoch plus 1. Go by number epochs. Loss is running loss. I think that should be correct. Only thing I might change, I'm going to put 100 over here. And this might take a little bit longer, but hopefully if there's no errors, and then we'll explain the code again. Yes. Exactly what I wanted to see. Yay. It's so easy to make mistakes with PyTorch code. And although I did prep this video a little bit earlier, I make a lot of typos. All right, great. So, great. So you can see like our first epoch we lost 1.89, right? Then just kept going lower, right? Number 9, 0.11. First time I wrote this code, I only did 10, but I was like, I wonder if it got better. And knew it would. Look at that loss. It's practically 0. Love it. All right, so let me just explain how this code works again. So number epochs, it should be self-explanatory there. For epoch and range, again, stuff we've done before, model.train. This time we're going to have a running loss here at the top. Then we're going to take a look at each batch within this train data loader. This goes back to over here. We set our batch size, right? So you can change your batch size number, but we define that in our data loader, right? And then we're saying for in this data loader, we take a look at our inputs is the batch data. Now this goes back into our data set, right? We said the train data set. Well, we created this class over here that's self.data and self.target. So we're grabbing the data over here. We're grabbing the target, our X and Y. And then we're pretty much running like what we normally do within this training loop, right? 0 grad. We grab our outputs. Then we take the loss at the criterion, loss backwards optimizer step. And this time we're plus equaling the loss.item detaches, right? So then you have just this loss over here as a number. And that's why we keep adding this up over here. And this is just a print statement. Right out if you really wanted to. Just good for visualization, at least on that side of things. All right, so now here's our evaluation. So let's do our evaluation. So first, let's set our model to eval mode so that way we don't calculate any of the gradients. So model.eval, then we're going to say all predictions equals, and we're going to just put empty brackets in there. All targets equal good over here. So we're going to say with torch.nograd, and I know I've been switching between videos. I've been putting either torch.nograd or inference mode. I've seen both used. So I'm going to show you guys both. That way, if you see it in your workplace or examples online, you don't get confused. but this is kind of like our new code over here. So this time we're doing for batch, and you should guess, right? It's gonna be our test data loader, because now we're doing, instead of our training, our test over here. So same exact type of thing, right? And think if you can write out these next 2 lines of code. Maybe pause the video and look back over here what I did, because it's gonna be nearly identical, right? So pause the video. If not, like, no big deal. Honestly, you can just go back over here and copy. So we're gonna have our inputs and targets, which is gonna be batch data targets, right? Again, very similar code. We're gonna say outputs equal to model, throw our inputs in over here. Okay. Now we're gonna do our predictions, right? So predictions equal torch.argmax. And remember, this is a classification problem. So we just want to have a one-dimensional prediction of, specifically in this one, right? We're taking a look, go back to our data set, our digits. So 0 through 9 on those specific digits, right? That's why we have 10 different classes on this one. But that's why also we have this torch.argmax. Great. Then we can go to next line. We can say all predictions dot extend predictions dot CPU, then dot numpy. This is just some code to clean up for here, so we can see our accuracy at the very end. So don't worry too much about this. And extend targets dot CPU. This is just to close out this video, right? Great. Have that over here, and then let's just calculate our accuracy. So accuracy equals, and we imported in our accuracy score. I'm like fairly certain did. So accuracy score. Then we have over here all targets, all predictions. One final line. All right, we're gonna write this out. So print over here f, let's say accuracy test, and then just throw in your accuracy times 100, and then say 0.3f over here. I think we just need a percentage sign. We should be good to go. Nope, I have a mistake somewhere. Mistake I had, as funny enough as it was, I misspelled outputs. So I was like, why am I having an error? And yeah, make sure you spell outputs correctly. And you can see our accuracy, and this is going to be 98.611%. So kind of just to explain one more time what I did over here, right? So model eval, then we're going to get all of our predictions and targets, right? So we're going to get this through this width over here, as well as this for. So we're going to do empty brackets. So Torch no grad, this should be familiar. We're not going to grab our gradients over there. So for batch and test data loader, again, same exact code as we did in our training loop, except now we're going to take a look at the test data loader. Our outputs, same thing, right? Predictions, right? It's a classification type problem. This code over here, which converts our tensors now into our numpy, which makes getting our accuracy score a little bit easier. I know it's a little complicated, but not too bad overall. And we finalized with a 98.611%. Hey, you made it this far. I appreciate you watching this video. If you aren't subscribed to the channel, I'd really appreciate it if you did that. It takes a lot of effort to make these videos every single week. And by subscribing to the channel, which by the way is 100% for free, it does allow YouTube to share this video among other people that are going to be learning data science. Now, if you're going to continue to learn PyTorch, I'm going to have a new video out shortly on transformers. And again, just adds a little bit more complexity to your model.